Thank you.
Do this, and I'll let everybody in.
And let me share my screen and
Yes.
audio.
And let me know if you're able to.
It is screen sharing is disabled.
Okay, let me just fix that. Host tools. Yeah, you should be able to do it.
Okay, do you see my screen?
Yes, we can see it. Do you mind just changing your slide just to make sure it's all working?
Does that work?
Yeah, sounds good. Okay, so maybe we'll, Makarand, we'll just give a couple of more minutes. I think people are still coming in just to make sure we.
Yeah, sure. Absolutely. Private window picker.
Okay, I think we can get started. We have good critical mass, and I'm sure people will come in. So thank you everyone for joining our the second in the series of our AI for Social Good seminar series. And today, of course, I'm very delighted to have Dr. Makarand Tapaswi. He has done some fantastic work in the area for AI for social good. Just to give a brief introduction, Makarand is a principal machine learning scientist at Wadhwani AI, a non-profit organization on using AI for social good. I'm sure if you have not heard about Wadhwani, look it up. It's a fantastic organization doing some very, very good work. And he's also an assistant professor at the Computer Vision Group at IIIT Hyderabad in India, which is one of the premier institutes in India. At Wadhwani AI, he leads the ML aspects of developing and deploying several AI solutions that create social impact in education, health, and agriculture. And at IIIT, he works on projects at the intersection of video and language understanding, especially related to analyzing and generating stories. And I think that's very exciting, and we look forward to your talk, Makarand. The floor is yours. Makarand, I also made you a co-host in case you want to stop recording anytime. You can do it by yourself as well. But
Got it. Yeah.
you can go ahead.
Perfect. Thank you so much. Thank you so much, firstly, for this invite, and good morning to all of you. I guess it's a little early, probably, for university students to attend a talk like this, but thanks for joining in. So I'll talk a bit about some of our work today. I mean, this is not really my work alone. This is done by a large team of people. I'll also give a slight overview of what our organization is and what it does. But before we get there, let me give a very brief overview of some of our work at IIIT Hyderabad, which is to do with video understanding and narrative understanding and so on. If some of you participate in the main CS and machine learning conferences, would be very happy to see you there as well. And we can feel free to ask questions or chat about this later, or send me an email about it if you have questions. Okay, so back on track to AI for social good. We as an organization work in health, agriculture, and education. And I was just generating some images with Gemini, and this one popped up, and this seemed a little interesting, where one person is actually working both on health and agriculture at the same time with two screens. And it felt a little like, that seems appropriate. This is some of my days do actually now look something like this, right? So the context that I want to set up for this, for the organization and the work that we do is there are several problems now in, and have been there, honestly, in health, agriculture, and climate related aspects, and then also education. And these are not standalone problems, right? These influence and are interconnected and depend on each other. So, for example, malnourishment in children can affect their cognitive abilities and how much education they may be able to receive. Of course, malnourishment is also a function of agriculture and climate, and thus, whether farmers are able to do well at their agricultural practices is a function of education. So the entire system is a closed loop process where each of these aspects are interconnected, and they're of course also very complex, different across the world. Each country or even region in the country may have different challenges that they need to address. And the natural question is, AI seems to be this really good thing that has come by over the last few years. It's been there for a long, long time, but it's made a lot of splash and news in the last few years. How can we leverage it and benefit from it for solving some of these problems? And if we look back, kind of look at the UN Sustainable Development Goals, we have these 15 goals or a little more that we'd like to try and address various aspects of. And unfortunately, we're not on track to solve many of these by around 2030, which is a major problem. And we're asking the question of whether AI can assist with this aspect. So we'll club all of these use cases of AI and call them AI for social impact or for social good. Um, and the organization that I work at, Wadhwani AI, occupies a little niche. So I want to talk about the two edges of the spectrum. One is startups and big tech, of course, which typically focus on AI and associated problems, typically with monetary returns. And big tech in particular is really eager and interested in developing these large foundation models today, which mostly some of us working in academia as well are is just a pipe dream, right? For compute reasons. And so academicians end up targeting cutting edge fundamental research, developing those perhaps more efficient models and aspects like those. Of course, there are some academicians who also straddle both these worlds and also contribute to social impact, but that's typically a minority. And so the two edges leave a gap in the middle, which is the need for AI-based solutions that potentially have high societal impact, uh, are necessarily of low dollar value, because we are trying to kind of build these solutions for the underserved communities, what is commonly referred to as the global south. And to do these or to deploy some of these solutions, you would also need to consider having some sort of policy advisory and capacity building frameworks set in place for users to kind of go and use these solutions as part of their daily practices and lives. So this is where Wadhwani AI comes in. We are an independent, not-for-profit applied AI institute. Our primary goal is to build and deploy AI solutions to benefit currently working in India, but also looking to expand to other parts of the world. We work in three main areas right now: in education, health, and agriculture. But of course, are happy to and considering kind of expanding to other areas where AI can be effective. We started in 2018 and are primarily funded by philanthropic capital from Sunil and Ramesh Wadhwani, two brothers who are in the US. And many of our projects, now we have 25 plus of them across the three domains that I spoke about before, are funded also by Gates Foundation, Google, former USAID, Walmart, and other companies and their CSR aspects as well. So our operating model primarily looks something like this. We like to partner with governments or nonprofits or other kind of public groups that have potentially a large footprint in the in current systems and processes, and work with them to identify use cases based on some of the priorities that the country might have, and leverage existing data systems or digital systems if they exist. A key aspect of this is we are a small organization of about 250, 300 people, small in relative terms. But what that means is we're not able to have people go on the ground and actually deploy our systems, right? These are, we'd like to have them be million scale user systems. And so having health workers or frontline workers, for example, use these systems means we want to leverage existing government platforms, for example, to roll out some of our solutions rather than having our own people go and meet the end user. So we work and partner with these organizations, look at developing different AI models, in fact, even framing the problem in the first place, and then integrating these models or solutions into various public platforms with the ideal goal of, if things settle and things work out reasonably well, we'd be happy to transfer some of this information and know-how and the models themselves, of course, to these bodies to kind of take them and run them sustainably in the future. So if you really think of it, it's some sort of a connection between public systems that exist that may or may not be digital, using philanthropic capital to create some AI-enabled digital public systems. Okay, to do this, we have a very cross-functional team. I did a PhD in computer vision. I would really put myself as a machine learning researcher. Um, and I quickly realized that ML researchers is probably the smallest part of the puzzle of trying to have some social impact, because you really need those domain experts to tell you what are the key problems, what is worth solving, what is the problem formulation. You need product managers to kind of look at the whole solution as in a holistic framework. You need user design researchers and experts to go and conduct these interviews with various users who may be using digital technologies or AI technologies for the first time in their lives. And finally, of course, engineers to build them, and evaluation experts to kind of make sure that what we're doing is actually useful and perhaps even impactful. So we're lucky to have a cross-functional team at Wadhwani, and that's one of the key reasons I like to kind of work at this organization now. So some of the projects that we've been doing across the last 5 to 7 years are shown here. We have a bunch of work in addressing tuberculosis, which is a major problem in India. In fact, the problem grew in severity after COVID, as the care practices and other aspects kind of suffered a bit due to problems of COVID. We have some projects in maternal, newborn, and child health. Those are, and one of these is what I'll talk about in more detail today. But then also some projects in monitoring the disease and outbreaks aspects, support in the form of telemedicine, which is one of these kind of dreams of trying to reach to any person with a mobile phone and have doctor-patient consultations happen via the phone. We, of course, work on standard medical imaging tasks such as chest X-rays or dermatology or ophthalmology as well. In agriculture, we're working towards developing some farmer advisory chatbots. Thankfully, across all of these projects, we only have 2 projects with chatbots. And I think that's another aspect that I want to focus on. While if someone hears AI today, they always think of LLMs, especially ones that are not in the field. But I think there are many, many, many more real solutions that one can build that do not require LLMs, and LLMs may even be the wrong thing or an overkill perhaps to use for some of these solutions, as we'll see later. And so we have some work on farmer advisory through chatbots, but the other aspects also of using measurement or analyzing the quality of grains, which are very classic computer vision problems. And then in education, we work towards improving the foundational literacy and numeracy, trying to detect dropout across schools, and of course, English being an aspirational language in the country, providing means of spoken practice for college goers. So I'll now focus on a couple projects. But before I do that, let me talk a bit about the kind of work that we do in tuberculosis. And the reason I highlight this is to try and showcase that we'd like to follow a cascade approach in most of our solutions. We are yet to get there necessarily across all these domains. But the idea is if you intervene at various stages of the life of a particular problem, and look at how AI may help various AI models, not necessarily vision or language or other aspects, we may be able to provide a holistic solution towards some of this. And I think TB is a great example for this, where we have, I think, 4 or 5 projects where the first part includes trying to identify hotspots or regions in the country that are able to identify groups of where vulnerability of likelihood of TB is likely to be higher. This involves some sort of mapping of socioeconomic and demographic factors that we're able to create and then make predictive models for how many TB cases are likely to be found in a small geographical area. We've developed something interesting for screening for tuberculosis using cough-based models. And all doctors will say that cough is not a thing that shows cough is an important symptom for TB, but cough does not have kind of indicators of TB. But we are able to actually develop a model that is able to identify especially asymptomatic TB subjects, which is a major challenge in the typical screening process. We have some work in assisting diagnosis, for example, by analyzing the chest X-rays. Some work in interpreting these Lyme probe assay tests that essentially involve essentially tell you the drug that would be most likely applicable for treating the subject, treating the patient. And then a key aspect of tuberculosis treatment is it takes about 6 months, sometimes more, for the entire regimen to be completed. However, your symptoms kind of go away in the first 2 or 3 months. And what happens is the patients tend to stop taking their medication and drop off essentially the treatment regimen. So adherence to the treatment regimen is super important in this case because the drop off potentially can lead to drug-resistant variants of tuberculosis coming back, and then there are often, unfortunately, no solutions. So this is the kind of cascade approach that we'd like to take, and slowly, as we kind of hopefully mature, and we're trying to get to this aspect across multiple fields and domains in our organization. Okay, so in agriculture, I just very briefly mentioned we have this farmer chatbot, some pest and disease detection across a variety of crops. I think we're targeting 10 crops now. We started off with cotton as our first early project, cotton being an important cash crop in India, and analyzing the quality of grains in particular, which is a very tedious manual process right now, and trying to do this through a vision-based system. Okay, so in the other aspects of health, we are focusing on maternal, newborn, and child health in particular. And in this aspect, again, we have three or four projects. It's kind of a similar cascade of sorts where we have some work on pregnancy risk stratification, measuring the weight and height of a newborn using a video taken by a smartphone. And you would ask, why not just use a weighing machine? We'll get into those details very soon. Trying to kind of predict the growth curves for children, forecast the growth curves for children in the interest of trying to detect, have early indications for faltering potentially, and then extending this work on anthropometry for newborns up to 42 days of age, up to 6 years of age for older children. So I'll talk now in a lot more detail about our work on newborn anthropometry. This was one of the first projects that I started off with as well when I joined Wadhwani back in 2020. So India has a neonatal mortality rate of about 25 per 1,000 live births. So this was about 5 years ago, and this has gotten better. But neonatal mortality is one of these things that can often be cured or like addressed based on better nutrition, both for the parent, both for the mother, and then the children as soon as they're born. And so deaths are often correlated with low weight. Now, to to address this problem, the government of India, and as I mentioned, we want to build on existing public systems, right? So we have these accredited social health activists, ASHA workers, that go home to home about 6 times in the first 6 weeks of life of a child, and then go and measure the weight of a baby using some instrumentation that we'll look at. So I'll stop sharing my screen for a moment while I show this video, and then we'll continue resume sharing from there. Oh, sorry, stop. We were doing this scoping at the beginning of, I think, 2019. And they found this sheet in the field settings where the sheet talks about essentially the newborn babies, some sort of home visit instruction or notice board of sorts. And what it's essentially reporting is the names. I've just masked them out using Gemini and done a reasonably good job at that. Um, and so it has the date of birth and so on, and then it has the weight at birth, and then it has the 6 visits or the multiple visits that need to be done to kind of make these readings further on. Now, if you look at this column in the middle, something very interesting pops up, right? So 9 babies born across several months, about 8 months at various times. They all tend to have a weight of 2.5 kg. Right? Now, what are the chances of that happening? So it turns out that 2.5 kg is the cutoff for calling a baby a low weight baby, and then therefore providing extra care or making more visits or all sorts of other aspects, right? So due to all the challenges that I mentioned before and various other genuine factors, including Ashas needing to walk tens of kilometers with instruments to measure the weight of a baby in hot summer, maybe 45-degree temperature and so on, 45 Celsius. And so these are some challenges that kind of result in unintentional data fudging, or basically misreporting of babies of these values. So what we're thinking of is, can we kind of get away from the conventional approach? And we just saw the approach for weighing a baby. The approach for measuring the length of a baby is extremely tedious. You literally need to flatten a baby out on this infantometer board of sorts. And every baby cries the moment you touch their knees and kind of push them down like that. So kind of, can we get rid of this tedious process and use some sort of vision-based method that may even work on low-end smartphones to facilitate this aspect? So we were able to collect some data and do this. I'll play this video as a short demonstration of some of it. Is primarily done through this existing system and protocol called the home-based neonatal care protocol, where Ashas is supposed to visit on these days. And often they'll do visits a few days before or after these schedules, and that's usually okay for us. And so we had a lot of help from the organization called Seva Rural and PGMER in Chandigarh, both in India. We were able to collect a video data set of about 13,000 or 14,000 visits, and about 4,000 newborns. The numbers here look a bit smaller because of some validation some data was lost during data quality checks and validation. Right, so this goes in as part of the main model training and evaluation phase. I'll quickly talk about the results. So across different visits, we see that the error is lower than 10% or less than 200 grams for about 80 to 95% of the visits, which is considered pretty good. If you look at a scatter plot, you can do the typical scientist thing that we love to do. The prediction dots lie fairly close to the ground truth, which is a good sign. And this orange line is also close to the blue line, the y equals to x line, which also indicates that there is not too much of a skew. Beyond weight, we can also predict the length, as I mentioned before, and the mean absolute error, essentially the gap between what was the ground truth and the prediction, the absolute value of that, and the mean across all your data, or the test set in this case, is also fairly small. And the length and head circumference and just circumference predictions also kind of do reasonably well. In fact, I think these lower than 1 centimeter is basically impossible because ground truthing itself is typically done at the level of 1 centimeter. And all of them also have relative errors that are pretty small. Now your question is 114 or 115 grams. That seems like a lot. So it turns out that it's hard to convince people that 115 grams is good. If that number was below 100, I think that would have helped psychologically, just like two-digit numbers. But then what we did was conducted a small study, and we're kind of working on extending this now to get a sense for if you had used the normal spring balance that exists, or even if it doesn't exist, we'll give you a new one, which actually skews the results to be better than they are. What are the actual readings that you'll end up taking, right? And so it turns out that if you use the conventional methods, you'd end up with a MAE around 183 grams, which is way higher than 114. And you can kind of make a plot of that as well, a percentile cumulative plot to show the distribution of how are the errors increasing over the number of samples. And you can see that the AI model thankfully does better. Top left is the better region versus this conventional practices method may not do as well. Right? So we're fairly happy about this, and we were able to convince some states to also go ahead and play with this model that we have and work towards deployment. One key aspect of deployment naturally was healthcare workers are going visiting rural parts of the country, and model compression comes into play. So we had ResNet 50 to start off. If I remember correctly, that's about 25 million parameters. We were able to compress that down to about a quarter of the size in the number of parameters, and then have that run on low cost smartphones, right? So these are smartphones about $100 to $120 of sorts, and they take about 15 to 20 seconds to run, but the video itself also takes about 15 to 20 seconds. And so, yeah, Ash, the healthcare workers are fairly happy about this aspect and quite eager to use this solution instead of resorting to tedious weighing machines. Now, one thing that we also are working and actively doing as we enter more states is this thing that we call contextualization, or essentially fine-tuning. This model was trained primarily on data from 2 states in India, and as we go to more states, we are seeing differences both in the differences in the distributions of the input data as well as the output data, um, output label space. And therefore, some sort of fine-tuning or contextualization often helps in kind of improving the quality of the model as compared to just throwing it out there zero shot. But I believe as we scale up to more states and more parts of the country are covered, the need for contextualization should probably reduce just based on more data helping improve modeling. An open challenge in particular in this task of anthropometry is very interesting, that I find fascinating, is normally when you deploy an ML system out there, you're always able to collect some data, get some annotations, and evaluate your models on an ongoing basis to get a sense for, is the data drifting, is the model drifting, are there some issues that you might want to arrest. With a system like this, you cannot annotate the weight, right? No human can watch a video and say that the weight of the baby is 2.68 kilos. So we naturally have this problem where ground truthing becomes an extremely tedious process while trying to do inference. And you could imagine that you would say, hey, some random health worker should carry a weighing machine, but no, they don't come to a central place where you can kind of distribute these weighing machines. So these are really open challenges, and it's not clear how we can do like systematic monitoring. We can do some sort of monitoring, and is that then sufficient to kind of have faith in the system and in the long run, right? So these are challenges to kind of work into, and then further improvements based on clothed babies, for example, is one more thing to look at. So this is some of our work on newborn anthropometry. Now I'll switch to our work in education as well. This is primarily to kind of support or evaluate foundational reading ability. Now, reading is a very important skill. Again, COVID had its effects where students, especially in lower grades, did not go to school, and therefore their ability to read grade appropriate passages went down dramatically. So there's this report that comes out every year, Annual Status of Education. So in 2024, the report said that about 55% of grade 5 students are unable to read a grade 2 level text, right? Now, this is a major problem because reading being such a foundational skill, you now just kind of think of what that means for their further development and further studies. Thankfully, the 2025 reports, I think this number has gone down to something 40 something, which is a good sign. But so the wave due to COVID has perhaps gotten a bit pushed out. But this is still a large number, and you'd ideally like this go down to zero. And in fact, then have this grade 2 students be able to read grade 2 text, right? As one would expect. So reading assessments is one thing that we started to look into actively, as reading is a very foundational skill. And this one quote or one set of phrases that I really like is, as students, I mean, young kids really go to school, they learn to read, and then that learning to read really enables them to read to learn, right? Much of our learning now happens in an older age by reading, but if you're not able to read, then you can just imagine what you're trying to learn. And the way current systems try and assess reading fluency or ability to read in schools is teachers doing this one child at a time, which, as you can imagine, does not scale well at all. Right? So the obvious question again is, can we somehow automate these assessments and also gain more information while doing so? Now, some of the classroom realities I'd like to point out before proceeding further is, this is not true for all schools, of course. There are very good schools as well in India, but there are in rural parts especially, there are, and even urban parts with lower income groups. There are schools which are essentially one room, not too big a room, and you'll have basically one teacher talking to a group of 30 to 40 students with a high student to teacher ratio and multiple grades. For example, all the kids in the range of 5 to 10 years in that classroom, right? Because there's only one school nearby and that's the one that they can go to. So you can imagine the plight of this teacher who, however well-intentioned, needs to somehow communicate different subjects, different information to extremely large variations of students in the class that they're sitting. So students are needing to be taught not only different subjects, but different levels, and not even in the same grade, but different grades as well, right? So all of these challenges kind of really come together and make reading assessments quite hard. Okay, so I wanted to give a very brief overview of what reading might sound like. Now, this is in Gujarati. Don't worry, Gujarat is a western state in India, and we deployed this in Gujarat and Rajasthan, two western states in the country. Don't worry if you don't understand the actual words. I think what you should try and listen to is the process in which reading is happening, right? And you'll hear the fluency even if it's a different language. Right? You can see that the child is struggling with putting letters together, blending words together, and essentially having a genuinely difficult time. Even says, I'm scared, I don't want to actually go and read these paragraphs, especially read paragraphs on the phone, because this is kind of new and too much to do for them. And this is in one classroom while you have another.
દરબારમાં બેઠા બેઠા અકબર બાદશાહના મનમાં એક વિચાર આવ્યો. તેમણે દરબારીઓને પૂછ્યું,
who is really fluent and is able to kind of rattle out the words in a nice way, right? And this person would then ask, can I read more? And so you have this kind of dichotomy again in the same classroom for varying levels of reading that may appear. Right. So the thing that we kind of developed at the beginning was this principle of, let's try and have some grade level assessments or grade level paragraphs that are obtained and have students read them. Based on that information, we'll kind of create some sort of scores for each child, in particular looking at something called the CWPM, which is the number of correct words read per minute, which is, let's say, a general way of measuring goodness or fluency of reading. And then you can kind of indicate to the student and to the teacher what sort of remediation activities are appropriate for this child, right? The teaching, the remediation, the assessments themselves as well are all happening through the teacher in this case. It's not that the student has access to some phone and they're just going and doing this on their own. And then you have individual results for the entire classroom, and you can do all sorts of various analytics based on that. So a very brief technical overview and one point I'd like to highlight. So given a grade level paragraph, you ask a student to read it into their mobile phone, do some basic pre-processing, and we need to transcribe the speech, right? Now, one key point, like many of you probably are aware of very good automatic speech recognition systems. They are all over now in our phones and everywhere else. There's a small difference between kind of speech recognition, which is trying to understand what you intended to say. It is trying to transcribe what you said, but more like what you intended to say and trying to gloss over some of the errors that you may be making, grammatical or otherwise, and basically get to the key point of the message that is being conveyed. In our case, we don't want to do explicit ASR, but we want to try and get the exact transcription of what the student said. And that actually turns out to be a fairly interesting technical problem in itself, right? Because ASRs are very eager to kind of gloss over some of the mistakes that the students may be making, especially ones that have some language models inbuilt, such as OpenAI's Whisper. And so we are able to kind of fine tune an existing adult speech model for Gujarati and Hindi, and then get it working for children, also for children with reading difficulties. And that was kind of the interesting part. And then you compare the transcription against the matcher, against the grade level original paragraph. And you now get a list of, hey, here's the set of correct words, incorrect words, and so on and so forth. Okay, so the model does reasonably well. I won't get into the details of this. But how do you actually now design this system for scale and community? And that was one of the key aspects that we had to work on. So we started out by looking at what is good reading. Let's start there. There are some global proficiency levels that have been established that talk about not good is basically converting numerical mappings to various levels, right? And suggesting remedial activities based on that. However, if you actually ask teachers about what do you think is good reading and how would you classify your own students, they have a very different outlook towards this, right? And so it's one of the takeaways for us is it's important to understand what the teachers know, what the current ecosystem is aware of, and more eager to try and work with, rather than enforcing some sort of external proficiency framework that has been developed to perhaps that is not applicable in those settings that we're working at, right? So the teachers would probably say something like students they would classify students into three main groups. So ones that cannot read, typically with very low confidence. They may not even be able to decode what the symbols are supposed to sound like. And especially in Hindi or Indian languages, we have these things called Zodakshar, which is two consonants connected to each other. And those words are especially difficult for those cases. We may have some students who mostly can read, but will probably read with many mistakes or pauses or challenges of confusing some sort of letters like this. And then you have good readers, right? So who generally do well, but may struggle with really long words. And so all of these now require different sorts of interventions. All of these also need to be assessed differently. Giving the same paragraph to all the students and asking them to read this is too much cognitive overload. So what we thought of doing was converting this categorization into some sort of icons or indicative language that is fairly easy to understand. And so we thought of talking about the speed and accuracy of reading into four different categories of like the student is a seed level state of the reader, a sapling, a flower, or a fruit, which is the mature stage of reading. And so essentially this framework actually worked fairly nicely with all the teachers and the students, and everyone was quite happy to see nice pictures reflecting their state of reading, even if the numbers look poor sometimes. But nothing was red, right? Nothing was red and damaging to the morale. So we took this, and then we also worked at assessing at the right level, which was showing this grade level paragraph as a first start, but then giving the teacher the ability to decide when they want to switch. So if the student faces too many challenges with the grade level paragraph, just pause, don't stress the child too much. There's no point in doing that. And come down to a simpler fluency level paragraph. And even if that even faces more challenges, just come down to simple words, right? And so reading assessments are often done in this scaffolded manner where you're going from what would be appropriate for that level, perhaps, to simpler forms, which we now are able to support through our system as well. And so all of these would then allow us to get some sort of actionable results. So a teacher typically does this across her class of 40 students, may not necessarily be at the same grade, and that's okay. But you still get a categorization or cohortization of your entire classroom into these 4 different categories that we've talked about before, and not just purely based on some reading speeds, but also ability of identifying letters, identifying groups of words that teachers are more familiar with or recommend for doing categorization. But of course, in the backend, we have all the individual results for all of these things, and you can still see the correct words per minute of every student. And especially the good readers are really interested in this and eager to compete with each other. Hey, what CWPM did you get? And I got 78 and you got 79. Oh, what did you do better? And so on. So that was kind of interesting to see. Right, so this system was actually deployed during the school year 23-24 in Gujarat, which is this western state, and we were able to conduct about 5 million assessments, again, with the support of the government of Gujarat, the state education department. We were able to onboard about 124,000 teachers, and about 3.1 million students did at least one assessment. Several did multiple, which is kind of exciting for us. So this is kind of one of the larger deployments, even among most projects at Wadhwani. This covered the entire state across all the districts, and therefore we also got a lot of interesting data about different dialects and all of those typical challenges of varied linguistic behaviors across, even within a state. We were also happy to do this in Rajasthan, now in Hindi, and had similar numbers with students, about 2.6 million of them reached, and assessments over 6 million. This was over the academic year 24-25, and we're now actually conducting some sort of baseline endline studies to see if we're able to show some sort of basic improvement by just doing multiple assessments and planning for further remedial activities. Now, the best part about all of this, so the MBA, the newborn anthropometry solution, was deployed on the phone. So the inference time costs were essentially zero. We have also worked on developing some models that can run on the phone for this solution, and therefore can bring the inference cost down to zero. But currently we deploy them on the server, and the cost is like 0.06 cents per minute or two of recording, which is great because essentially we can process all those 3 million students in a couple $1,000s, right? And that's actually a very important factor to make sure that you're able to deploy these systems at scale in a cost-effective and appropriate manner. The final thing that I want to bring out is we were not only kind of looking into having these be run in the school, but also having parents know about these aspects, right? And the State Department also was happy to kind of work with us in integrating these results within the report cards of students. And so parents came back to us and were interested in knowing more about the reading assessments. And therefore they have these conversations now starting at homes where they're talking with their children about reading being an important aspect of learning. And not something that is restricted only to the schools. And then in Rajasthan, they also went a step ahead and were happy to come up with various remediation strategies based on the different categorization that we were able to do. Okay, so the takeaways for me for all of this work is I think AI is more than LLMs, for one. I think generative AI has filled our heads with a lot of hype and buzz. But I think if you want to develop social impact solutions, and I think as I showed the list of projects that we're working on, most of them are not being solved with LLMs and probably should not be solved with LLMs. Foundational models may still help in terms of perhaps extracting better representations, but throwing billion scale models at problems that need to be operating at billion scale is not necessarily a compute uh, budget friendly option, right? Which is something to be aware of. And I really like this quote about all models are wrong and some are useful. Extended further by saying small models in particular can also be still very useful. Um, so the other thing that really kind of excites me is we get to engage with the community a lot, really understand the challenges that they're facing, and identify the problem in a better way rather than sitting in our offices and labs and trying to make up some solutions just for the sake of saying, hey, let's develop something, right? Because that ends up not being used. And then finally, I think as a technical person, the real world challenges are really crazy, right? Like in anthropometry, for example, we were not able to collect ground truth during deployments, which brings us into all sorts of interesting questions about how do you figure out whether model predictions are reasonable, right? So these are, again, I don't have the answers to them yet. But you can do all sorts of various distribution matching methods and unsupervised approaches to see how you can leverage some of these ideas. And then in reading fluency, I think not ASR, but transcription was one of the key kind of things that we had to learn. This was relatively easy in Indian languages because most of our languages have scripts that you read as you see. So that makes it fairly easy to deal with. English is a pain over here because what we needed to do to get this to work really was to annotate or collect some annotations for children not speaking well, right? Not reading well. Now, if a child is not reading English well, transcribing that is not trivial because you need to make up some English letters, essentially, the wrong ones. And because the same kind of letters make different sounds in English, it's not clear which letter to impose when the wrong sound is heard. So this is a major problem that we're kind of also working with currently, which is resorting to using Hindi letters when the children make a mistake, because that has a relatively better mapping to phonemes and basic sounds. So yeah, these are some of the technical challenges as well and interesting problems to kind of work on. So with that, I think thank you for your attention and happy to take some questions.
Thank you, Makarand. Honestly, fantastic work. And the best part is, the work is actually at the ground, which is amazing to see how, our AI technologies and all the buzz, as you rightly said, the LLMs are not the only ones that are out there that can make an impact. So fantastic. So before, yeah, we have time for questions. Just unmute yourself, I would say, and it will be nice if you can put on your video before you ask a question so we can see who that person is. So yeah, we have time for questions. You don't get the opportunity to talk to somebody with an AI for social good with a high impact. So it's an opportunity for everyone here. If not, then I have a Prashant. Yeah, go ahead, Prashant.
Yeah, so nice work, Makarand. And yeah, it's good that you are working on social good, and it's very few people who work with the advanced AI technologies on social welfare. So I was just curious about the stream balance, the weighing thing, right? So why doesn't the government can't give a pan like or I mean digital scale, usually like how they do it in a government hospital? Or are these people, they don't want to carry the weighing machine?
Yeah, so good digital weighing machines typically weigh 2 to 3 kilos, 3 kilos at least, and they're fairly bulky as well, right? So walking around with those things is not trivial. That's one aspect. And the second thing is actually if you go through the cost calculations of those with a million ashas and several thousand rupees on these things, which by the way go out of calibration fairly frequently. We did a lot of ground truthing activity, and so we know like we needed to tune these systems every few months. Yeah, that all of that comes together to kind of make this a really crazy supply chain problem.
I see. Okay. Yeah, I expected that. Yeah. Okay. Thanks.
Anybody else?
And who funds all this? Like, any idea? Is it like donations or government funding or?
Right. So I think slide before this. Yeah. So some of our work is the
Oh,
work
okay.
on
I
newborn
didn't know.
anthropometry was funded by Gates Foundation actually. And in general, we're happy to have had funding from Google.org, USAID in the past for all of our work in tuberculosis in particular. And yeah, so various other philanthropic bodies as well as CSR bodies. There is basic funding core support from Sunil and Ramesh Wadhwani as well, which I want to acknowledge, of course.
Good. I think there's Dr. Paul wants to ask a question. Dr. Paul?
Yeah, that was a really interesting session. And unfortunately, I joined a little late, but I could grab most of the things that you were saying. And interestingly, the place I work is the Albag Educational Institute. And the work that we do is quite relevant to social perspective as well. So I also keep on working on AI and social needs. And your talk was very relevant. And one thought that I was wondering was, it's so interesting that you are tackling reading as a metric for analyzing students, especially the age that you're talking about. But can we think and extend the idea in general as learning? So reading may be a part of a learning, but learning is actually, if I read, uh, I am not really sure that how much a student has learned
Yeah.
the content or the meaning of what a person is reading. So,
Right.
reading and matching the words while speaking is one measure, for sure, a good measure. But how do I really understand that has he or she comprehended the meaning of the things that one is learning? Maybe that would be useful for a little higher classes. But yes, I was wondering about ways and means for doing that.
Excellent. Actually, this raises an important question, right? I think the one of the key aspects for this for us was, um, first of all, I think reading is an important foundational skill to be able to learn things. So, I mean, you can learn visually, yes, but I think there's a limit to um, only visual learning without any letters and words, perhaps. Because I mean, we've developed language as a way to kind of communicate, and that really helps humans get ideas across to each other, right? And so I think reading in that sense is important. To measure learning, we've also started to look into developing some very basic comprehension tests on top of the paragraphs that they've been reading. And again, we're working currently with the state of Rajasthan for this, where we have three questions that show up optional currently that students can try and attempt to understand their level of comprehension of these paragraphs. And so I think what excites me in this aspect now is you can come up with different levels of questions, in the sense different complexity of questions, perhaps have an LLM perhaps run them once. You have 100 questions for each paragraph. And then depending on the information that you have about the student, show them like what you expect to be level appropriate questions for them to try and address, which is kind of an exciting next direction. We're also working on numeracy, which is kind of basic arithmetic, or just even mapping visual cues in an image to like how many balls do you see in the picture, stuff like that, right? Um, and then kind of trying to put together reading and numeracy into kind of one foundational educational aspect of school. But yeah, I think this is a very important aspect, and we keep talking about learning outcomes, learning outcomes. It's not, you need to make that connection between reading levels and learning outcomes before claiming impact.
Yeah, that's interesting. So thanks that you replied back. And interestingly, we can also insert some ideas like Bloom's taxonomy in the level of questions and coming up back with the
Yeah.
answers. But
Yeah, we use one of them.
I tried one experiment. I normally teach AI at undergrad level, and there is a subject which is AI for everyone. That's another subject. So the dilemma comes that if you ask questions about AI, there are various things, and some of them are common. And students at various grades give some replies, and it is really tough and challenging to evaluate the answer as such.
Yeah.
So we were looking forward for various, genuine ways to kill the subjectivity of the answering of a student and be more objective in analysis. So thanks. I mean, your talk have provoked us with many new ideas, and thank you for your talk.
Thank you so much. And there's a lot of interesting work on tutoring and assessments using AI, mostly using LLMs now, but for open-ended questions. But I think we currently go sort of questions which reduces
Absolutely.
the teacher is there to do the grading.
Yeah, thank you. We have a
Thank
question
you,
from.
Apoorv. I would
Thank you, Dr.
like
Paul. We have a
okay.
question from Rishabh. Rishabh, you want to go ahead?
This question.
Sure, Professor. Thank you. Hi, Makarand. It was a really great talk, and sorry, I was also a little late to join the but yeah, I guess my question here is that do you believe it would be beneficial to incorporate other modalities as well for assessing the reading fluency? Like you did talk about the phonemes part, but like would it be would it have any benefit to include voicemes as well?
Yeah, simple short answer. Yeah, I mean, see, I think as technically minded people, especially I'm a vision researcher. I always want to capture inputs whenever possible, right? And we have the phone, the camera is sitting right there, the student is looking at the phone. And so we have actually indeed thought about, can we try and capture eye gaze? Are the students looking at by line in the right order? Maybe that's causing some reading difficulties. I think, yeah, definitely was thinking about, there is a question of whether the costliness of that aspect would then blow up, because sending video across the internet, and so maybe there are get gaze tracks and lip movements perhaps to try and then make this process simpler. But yeah, definitely something interesting to look into.
Sure. Thank you so much.
Okay, so before we end, I know we have a lot more questions, but I'll give a chance to Arat to ask the last question, and others certainly, I'm sure we can always reach out to Makarand later on over email, and he'll be happy to answer all the exciting questions. The talk recording will be available after, with some parts removed as Makarand requested. But yeah, Arat, please go ahead.
Hi, Professor. Thank you for such a great talk. I had this question about have you correlated any outcome with the language proficiency and how the children are actually developing and how their levels could actually correlate with what they do in later part of their life? So, interestingly, I think a year ago I came across this study. I was talking to someone that he told me that there's a correlation between how mathematics is actually taught to students and what they actually do in life and how they choose academia later on and they choose to go to college or not. So is there any correlation that you came across that is interesting in this way in the form of language assessments like this?
Yeah, I don't know. I think we need to look into this. I, I mean, you raise an interesting question about the way in which reading assessments are conducted, or I would say probably the way in which reading teaching is conducted is probably more likely to influence students' liking towards reading, perhaps. Um, Way in which assessments are conducted, I don't know. Uh, yeah, something to look into.
Yeah,
Very
that would be
interesting.
interesting to see.
Yeah.
Thanks. Thank you, everyone. Maybe Makarand, I just wanted to, maybe a quick short comment from you would be very helpful, because one of the key things that I see in these projects, besides technical part, is just getting the community engagement is a very, very hard challenge. And I know you have Wadhwani supporting you, while for a lot of other researchers who are trying to make that impact, it's getting that community engagement is very hard. What would be your thoughts on that, for, to get that engagement going in? Because that is where the hard part, like you already saw the whole problem where people were not willing to put in the right values. Right? Yeah.
Yeah. Um, yeah, I think absolutely this is why I work at Wadhwani. Short answer. I mean, over the few years, 4 years that I've joined university as well, I don't think it's easy to kind of be the one-man person in show to really pull off projects at such scales, right? And I think consortia in academia sometimes do pull off some miraculous things, and I have even wilder appreciation for them. But I think it's so the key takeaway, it's a slow process, right? Even with the people that we have at Wadhwani who have good connections, often at the ministry or various government bodies. Like for the tuberculosis work, we now are the official kind of the AI partner of Central Tuberculosis Division in India, which takes care of everything in TB. But that partnership and that alliance took like a couple of years to form, right? So I think keep at it. We have people from Wadhwani AI sitting at various ministries and, co-working with them, really trying to understand their problem. They are equal stakeholders along with the users that you want to try and impact, right? They are also equal stakeholders. They have their own set of problems that if you can kind of help with, then they may be more willing to work with you for kind of getting some of these solutions going ahead. I think India is also in a currently um, there is excitement to try things more than necessarily trying to regulate and clamp things down, which is exciting. It's also can be worrying if used wrongly. But kind of balancing both of them is important responsibility, I guess, to kind of take this forward. Yeah.
Oh, fantastic. No, thank you. This is excellent. So, yeah, I think let's thank Makarand once again for a wonderful talk, a very impressive and impactful work going on. And I think that gets us excited to do more cool things. And if, sure, I am sure if anybody has any other questions, just ping Makarand. I'm sure he will be happy to uh, see you guys answer your questions. And thank you so much for taking time for us.
Thank you so much for the invitation. This is lovely, and have a good day, all of you.
Thank you. Have a good night. Bye bye.
Bye.